Hi everybody, this is the second video on solving higher order polynomials with a focus on factoring. If you didn't watch the first video, go back and watch it because I'm going to spend a lot more time on this slide in the first video than in this one. Okay, so our steps are to set the equation equal to 0. We always want to remember that we're going to be working with equations. That's why we're solving, because we have an equation. We're going to try and factor completely. We're going to set each factor equal to 0. And then we are going to solve for that. We're always going to be checking to make sure that our degree, which is the highest exponent in the problem, matches our number of solutions. These solutions might be real, imaginary, and or repeated. It's going to be really tempting when you look at a problem like this one to solve that by taking the cube root. There's a problem with this. There's only one cube root of 8. And while 2 is a solution to this problem, I know, by looking at the degree, that there have to be 3 solutions. Back to the drawing board. So I'm going to instead attempt to solve this one by factoring. I'm going to set it equal to 0. And hopefully you notice by structure that this is a difference of cubes. The difference of cubes has a formula. I think now would be a good time for you to pause the video, because I'm going to factor this one pretty quickly. I think it's good practice for you to factor it on your own. Here I go. This factors to x minus 2 times x squared plus 2x plus 4. If you're not sure if you've done that correctly, multiply it back out and make sure that you get x cubed minus 8. Now, just like I did the first time, I see this answer of x equals 2. Now, I already knew that that was a correct answer, but I can see with this trinomial where the other 2 solutions were hiding. Now, with small numbers like that, you can give a try factoring. But if you do, you're going to realize that this is not something that factors. When you plug it into the quadratic formula, you can see why not. If you were an Algebra 1 student, you'd get to stop here, because we're taking the square root of a negative number. All right, I get negative 2 plus or minus the square root of negative 12 over 2. That is the same thing as negative 2 plus or minus 2I root 3 over 2. Now I'm going to remember that the quadratic formula gives me all of my solutions, which are x values. And I'm going to reduce this to get negative 1 plus or minus I root 3 over 1, or negative 1 plus or minus I root 3. So now I can finally see my 3 solutions. I've got x equals 2. That's a real solution. And then 2 imaginary solutions. One for the negative 1 plus I root 3, and one for the negative 1 minus I root 3. All right. Hope that was helpful.